NASA versus China. Who will spy on the universe from the moon first? Find out here. Hint: it has something to do with building a huge telescope on the moon. First of all, you may be wondering why we need a lunar telescope in the first place. Well, let me tell you a secret. There's a whole part of the universe that we can't see from Earth. And it's not because we need glasses. It's because some radio waves are too long and lazy to get through our atmosphere. These radio waves are longer than 10 meters, and they have frequencies below 30 megahertz. That means they are almost invisible to us, but they're not invisible to the moon. And that's why NASA and China want to use the moon as a giant radio dish. But what are they looking for? Well, as you may know, radio waves can reveal things that are invisible to optical telescopes, such as black holes, pulsars, quasars, and even the first stars and galaxies that formed after the Big Bang. But why do we care about these radio waves? Well, because they might help us solve one of the biggest puzzles in cosmology, the dark ages of the universe. No, not the medieval times with knights and dragons, the dark ages of the universe, when the first stars and galaxies were born. But there was a problem. The universe was full of a thick fog of hydrogen atoms that blocked all of the light. So the first stars and galaxies were like shy kids who hid behind the fog and didn't show their faces until much later. But don't worry, because they left us a clue that we can only see with a lunar telescope. And that's what NASA and China are looking for. But what is this clue? And what will it tell us? Well, it's not a treasure map or a love letter. It's a very faint signal that they emitted when they were still hiding behind the hydrogen fog. This signal is called the 21 centimeter line, and it's part of the microwave band of the electromagnetic spectrum. The signal could tell us a lot about how the first structures in the universe formed and evolved. But there's a catch. This signal is not what it used to be. Because the universe is expanding, this signal has been stretched, like a rubber band, by more than 1,000 times over time. And now it looks like long radio waves with wavelengths of more than 10 meters. And as we said before, these radio waves are too long and lazy to get through our atmosphere, so we can't detect them from Earth's surface. So how can we see this elusive signal from the dark ages of the universe? Well, there's only one solution right now. We need to go to the moon. But not just anywhere on the moon. We need to go to the far side of the moon, the side that never faces Earth. Why? Because it's one of the quietest places in the whole solar system. It's protected from Earth's atmosphere, man-made radio noise, and even the sun's radio emissions during the lunar night. It's like a radio paradise. So it looks like the moon is our best bet, and that's why NASA and China are fighting over it. But they have different ideas on how to do that, and they're not very good at sharing. Let's start with NASA. What is NASA's plan for a lunar telescope? Well, it's called the Lunar Crater Radio Telescope, or LCRT, and it sounds like something out of a sci-fi movie. NASA wants to create a huge radio telescope inside a crater on the far side of the moon. How huge? Well, the telescope would have a diameter of 1.3 kilometers, and the reflector would be 350 meters in diameter. That's bigger than some cities on Earth. But how would they build such a monster? Well, they would use thin wire mesh that would be unfolded by robots inside the crater. The robots would also hang a receiver over the reflector to catch the radio waves bouncing off the wire mesh. What kind of radio waves are they looking for? Well, they're looking for radio waves that are between 10 meters, or 33 feet, and 50 meters, or 164 feet long, which correspond to frequencies between 6 megahertz and 30 megahertz. These are the radio waves that can tell us about the dark ages of the universe. But when will they do this? Well, not anytime soon. The LCRT is still in its early stages of development, and NASA hopes to launch it sometime in the next decade. So, what about China's plan for a lunar telescope? Well, it's called Hongmeng Project, or Discovering Sky at Longest Wavelengths, DSLW. And yeah, it sounds like something out of a sci-fi novel. China wants to put a bunch of satellites in orbit around the moon to create a radio telescope that can also see the long and lazy radio waves we talked about before. The satellite family would have one mother and 8 daughters. The mother would do all the work of processing data and talking to Earth, and the daughters would just listen to the radio signals from the farthest corners of the cosmos. The satellites would go around the moon in the same orbit, and they would collect data while on the far side of the moon. The mother would then send the data to Earth when she comes back to the bright side. The DSLW would zoom in on radio wavelengths between 10 and 100 meters, which match frequencies between 3 megahertz and 30 megahertz. This range also covers the redshifted 21 cm line from the dark ages of the universe. This line is a faint glow from neutral hydrogen atoms, which were everywhere in the dark and cold cosmos before the first stars and galaxies turned on their lights. You might be curious about when this project will take off. Well, you don't have to wait too long. The DSLW project is expected to launch in 2026 and operate for at least 5 years. So which plan is better? Well, that's hard to say. Comparing the two plans is not an easy task, as they both have their pros and cons. However, let's start by looking at the LCRT. The LCRT would act as a giant ear on the moon, listening to the secrets of the universe with high fidelity. It would have a huge dish and a sharp vision, which means it could catch every whisper and see every pixel. It would also be more steady and less bothered by the moon's wobbles than the DSLW. But building and setting up the LCRT on the moon would be a nightmare. It would require a perfect landing and a delicate unfolding of the wire mesh inside a cozy crater. It would also offer a narrow view and a longer wait than the DSLW. The DSLW, on the other hand, would consist of a bunch of satellites orbiting the moon, chatting with each other and sharing what they hear. The plan would be simpler and cheaper to launch and operate than the LCRT. The DSLW would also provide a wider view and a faster result than the LCRT, and the satellites could be easily upgraded or replaced by adding or changing them. However, DSLW would suffer from a weak antenna on the moon, missing some of the signals or details. It would have a small dish and a blurry vision, which means it could skip some sounds or images. It would also be more shaky and more disturbed by other satellites or junk. So which one do you prefer, the LCRT or DSLW? Well, maybe you don't care at all, and you just want to watch some cat videos on YouTube. That's fine too, I won't judge you. Thanks for watching. If you liked this video, please give it a thumbs up and share it with your friends. Don't forget to subscribe and hit the bell icon to get notified of our future videos. These things might sound repetitive, but they're very important for the growth of the channel. Thank you again. By the way, the moon is a very popular destination for many countries these days. But have you wondered why? Click here to watch our epic video about this topic. See you next time.